multiplication and division on radical expressions. Let's start with multiplication on radicals. In simplifying radicals, we use the product rule, and in this property, we can also use this one in multiplying radicals. Hence, the product of the roots of two numbers is equal to the roots of the product of those numbers. In short, the nth root of A times the nth root of B is equals to the nth root of AB. Let's have some examples in finding the product of the following radicals. Number 1. 4 square root of 5 times 3 square root of 18. First, you need to simplify each term, then follow the product rule or this property, the nth root of A times the nth root of B is equals to the nth root of AB. Then if possible, simplify the final answer. So for our solution, we need to simplify each term. Since we can still simplify our second term, which is cube root, which is 3 square root of 18, and that gives us 3 square root of 9 times 2. So 4 square root of 5 times 3 square root of 9 times 2. As we continue, you will have there quantity 4 square root of 5 times quantity 3 times 3 square root of 2. Then you have here 4 square root of 5 times 9 square root of 2. Next, multiply the numerical coefficient to the other numerical coefficient and radicand to radicand, and make sure this radicand can only be multiplied if they have the same index. Again, always remember, two radicands can be multiplied if they have the same index. So 4 times 9, that would be 36. And for our radicand, 5 times 2, that's 10. So your final answer will be 36 square root of 10. Number 2. A square root of AB squared times 2B square root of A squared B times 3AB square root of A squared B squared. In this case, follow the product rule, which is nth root of A times nth root of B equals the nth root of AB. Then always remember to simplify all the final answer. So as we continue our solution, multiply the coefficient. So you have here the outer coefficient, which is A times 2B times 3AB. A times 2B times 3AB, that is 6A squared B squared. While on the radicand, you have here quantity AB squared times quantity A squared B times quantity A squared B squared. And as we multiply the radicand, we arrive with A raised to 5, B raised to 5. So with that, we have here 6A squared B squared square root of A raised to 5, B raised to 5. This is not yet the final answer since the index is lesser than the exponent. Always remember, the index must be greater than the exponent. So we need to simplify the radicand. So in simplifying the radicand, we arrive with square root of A raised to 4, B raised to 4 times AB. Or shall I say, 6A squared B squared square root of A raised to 4, B raised to 4 times AB. And as we continue simplifying this one, we have here quantity 6a squared b squared times a squared b squared square root of ab. And as we continue simplifying in order to get our final answer, we arrive with 6a squared, 6a raised to 4, b raised to 4, square root of ab. And that is our final answer. Number 3. Quantity 2 plus square root of 3 times 5 minus square root of 3. This case, you simply follow the property of the nth root of a times nth root of b equals to the nth root of a, b, and apply the FOIL method. Then always simplify the final answer. So for our solution, applying the FOIL, our first term here is 2 and 5, so you will have there quantity 2 times 5. For the outer terms, you have here 2 and negative square root of 3. So you will have here quantity 2 times negative square root of 3. For the inner terms, you have here square root of 3 times square root of 5. And for our last term, you have here square root of 3 times a negative square root of 3. And as we continue simplifying this one, 2 times 5, that's 10. 2 times negative square root of 3, that's negative 2 square root of 3. Square root of 3 times 5, that's 5 square root of 3. And square root of 3 times negative square root of 3, that's a negative square root of 9. If you can still simplify this one, we can combine negative 2 square root of 3 with 5 square root of 3, and that gives us 3 square root of 3. While square root of 9 is 3, copy the remaining sign, which is minus, so you have there minus 3. If you have still terms that you can combine, combine. In this case, we can still combine 10 and minus 3. 10 minus 3, that's 7. So our final answer is 7 plus 3 square root of 3. Number 4. Square root of 3 times the fourth root of 3. Obviously, you cannot just simply multiply the radicand since the index are not the same. We have here an index of 2 and an index of 4. In this case, express each term into an expression with rational exponent, then simplify. So for our solution, we need to express each term into an expression with rational exponents. So you will have there 3 raised to 1/2 times 3 raised to 1/4. Since you have here the same basis, you can add exponent. So you will have here 3 raised to 1/2 plus 1/4. Since you cannot simply add this to fractional exponents because they don't have the same denominator, you need to look for the LCD of 2 and 4. For that, you have here 4. So our new expression will be 3 raised to 2/4 plus 1/4. 2/4 plus 1/4, that's 3/4. So you'll have here 3 raised to 3/4. Next, express this 3 raised to 3/4 into a radical form. So the radical form for this is 4th root of 3 cubed. And 3 cubed is 27. So the 4th root of 27 is the final answer. Number 5. Quantity square root of 2 plus square root of 5 times quantity square root of 2 minus square root of 5. The expression quantity A plus B and quantity A minus B are called conjugates. When multiplying conjugates, the sum of the products of the inner and outer terms results in 0. In this case, the property would be quantity square root of A plus square root of B times quantity of square root of A minus B is equals to a minus b. In short, you need to get the square of the first term minus the square of the second term. So let's try to look at this example. So in this example, you have your square root of 2 for the first term and square root of 5 for the second term. So we need to square the first term minus the square of the second term. The square of the square root of 2 is 2, and the square root of 5 is 5. 2 minus 5, that's a negative 3. In this case, negative 3 is the final answer. Next, on our second part of our discussion, we will have the division on radical expressions. In dividing radicals, or to divide radicals, we need to apply the quotient rule, and in the quotient rule it states that the nth root of A over the nth root of B is just equal to the nth root of A over B. Then simplify the resulting radicand if necessary. Have some examples. Direction: find the quotient of the following radicals. Number 1. Square root of 125 divided by square root of 5. Since we can still divide 125 with 5, we can then proceed to this solution. It is equals to the square root of 125 over 5. 125 divided by 5, that's 25. And square root of 25 is 5. And the final answer is 5. Number 2. The cube root of 4a squared over the cube root of 5b. Since you cannot divide the radicands, we need to look for a factor where we can rationalize the denominator. Now, recalling the lesson in our previous WLP 2.5, we have discussed about simplifying expressions using the quotient rule with rationalizing the denominator. And remember, in rationalizing the denominator, you need to look for a factor that can make the denominator a perfect cube or perfect square, depending on the index. Since it's cube root, we need to make it a perfect cube. So, in this case, our term will be cube root of 5 squared b squared, or the cube root of 5 squared b squared. And in short, we will have here the cube root of 4a squared over the cube root of 5b times 1, or the cube root of 5 squared b squared over cube root of 5 squared b squared. With that, you will have here the cube root of 4 times 5 squared a squared b squared all over cube root of 5 cubed b cubed. Simplifying the denominator and numerator, for the numerator you will have there cube root of 100 a squared b squared. For the denominator, the cube root of 5 cubed b cubed is 5b. And with that, our final answer is the cube root of 100a squared b squared all over 5b. Number 3. Square root of 8 all over cube root of 4. Since you cannot divide these radicals instantly, since the radicals are not sharing a common index, you need to express each term into an expression with rational exponents. Then simplify if possible. So in this case, you need to express square root of 8 into an expression with rational exponent, and that would be 8 raised to 1/2. On the other hand, cube root of 4 is 4 raised to 1/3. Next, we need to simplify 8 raised to 1/2 and 4 raised to 1/3. Since both 8 and 4 are sharing a common base, which is 2, we can express this one into 2 cubed raised to 1/2 all over 2 squared raised to 1/3, since 8 is equals to 2 cubed and 4 is equals to 2 squared. Next, multiply the exponents. So as you multiply the exponents, you arrive into 2 raised to 3/2 all over 2 raised to 2/3. Next, express the numerator and denominator. Next, subtract the exponent of the numerator with the denominator. So you will have here 2 raised to 3/2 minus 2/3. Since you cannot directly subtract this, you need to look for the LCD. And the LCD of 2 and 3 is 6. Expressing this one into the simplest form, you will have here 2 raised to 9 over 6 minus 4 over 6. 9 minus 4, that's 5. So your answer will be 2 raised to 5 over 6. Next, return or express the expression into our radicals, or transform the expression into radicals. So that would be the 6th root of 2 raised to 5. And since 2 raised to 5 is 32, that would be the 6th root of 32. And that would be the final answer. Number 4. 2 divided by quantity square root of A plus square root of B. To divide the radical with the denominator of the radical consisting of at least 2 terms, you need to rationalize the denominator. In order for you to rationalize this denominator with 2 terms, you need to apply the conjugate. So look for a term, or look for a pair of binomial that can make the denominator a conjugate, and that is square root of A minus square root of B. So you need to multiply quantity square root of A minus square root of B to the denominator and also to the numerator to rationalize the denominator. So in simplifying this, numerator to numerator, that's 2 times quantity square root of A minus square root of B. And as we multiply the denominator, the first term is square root of A, the second term is square root of B. Remember, if you multiply conjugates, all you need to do is to get the square of the first term minus the square of the second term. The square of the first term, or the square of square root of A, is A. And the square of square root of B is B. So you will have here A minus B for the denominator. With that, our final answer will be 2 quantity square root of A minus square root of B over A minus B.